Hello everyone. In this video, we're going to be solving a Diophantine equation. Well, these kinds of equations are actually pretty interesting. If we're looking for integer solutions, obviously there are infinitely many real solutions to this, but if you're looking for integer solutions, it's a Diophantine equation. Particularly, these are called Pell's equations. And Pell's equations are pretty interesting, and we can definitely talk about those in detail later because this is not a Pell's equation. Well, it kind of is, but with some restrictions. So let me go ahead and clarify that. In this particular equation, we're looking for prime solutions. What it means is that x and y are prime numbers, all right? So x and y are prime numbers, and we're going to try to solve this equation for prime solutions. So how do we proceed? First of all, I want you to notice that this equation on the left-hand side is not factorable because 2 is not a perfect square, and that's actually what makes it a Pell's equation, but this is not kind of like that. Anyways, let me just proceed. Well, 2 is not a perfect square, so the left-hand side is not factorable. What can we do then? Well, we're just going to use a couple facts: divisibility, parity. These are important concepts in number theory. Parity means whether something is even or odd, right? So those are important concepts, and we solve a lot of problems using those ideas. So let's proceed. I'm going to add y squared, 2y squared to both sides, and that's going to give me x squared equals 2y squared plus 1. Great. Now, what is that supposed to mean? Well, y squared is an integer, obviously. X squared is an integer, and 2 times y squared plus 1. So that means that we are getting an odd number here. So x squared is an odd number. All right, great. What does it mean for x squared to be an odd number? Well, if x squared is odd, x is also an odd integer. Now, one of the great things when you're solving an equation with integer solutions is that if you know that whether one of the variables or both are even or odd, then you can actually replace them with something. Well, we can use, for example, in this case, we can use x equals 2n minus 1, where n is, just an integer. Well, in this case, we're looking for, prime solutions, so n would have more restrictions on it. But anyways, we can just write x as 2n minus 1. Okay, now, having said that, we can just go ahead and replace x with 2n minus 1 on the left-hand side. Let's go ahead and do that. Replace x with 2n minus 1, and go ahead and square that. You're going to get 4n squared minus 4n plus 1 is equal to 2y squared plus 1. Obviously, in this case, you know that the 1 is going to cancel out, leaving us with a simpler expression. Moreover, we can divide both sides by 2, which is nice because it's going to give us something simpler. 2n squared minus 2n is equal to y squared. Great. And we can now factor the left-hand side. I think it was nice that we replace x with something. Now it's factorable, which is cool. 2n multiplied by n minus 1 is equal to y squared. Great. So you can do lots of different things here, obviously. N times n minus 1 is like the product of 2 consecutive numbers, and then multiply by 2, it needs to be a perfect square, but we don't need to do any of that. We're going to use a simple argument here, which is what? Okay, great. Now, we do have 2n multiplied by n minus 1, and these are both integers. You're multiplying them, but 2n is even. So the left-hand side is basically even, which means that the right-hand side also needs to be even. Okay, so what? Are we going to replace y with something like 2k? No, we're not going to go there because we don't need to. But remember that x and y are prime numbers. Since they're prime, the only even prime is 2. That's very unique, right? Okay, great. So y has to be 2. Okay, cool. Obviously, y squared is even, implies that y is even, right? And y has to be 2. Cool. Well, how do you solve for x? You know that x is odd, but that's all we know. Well, it's easy because we have an equation and we have the value of y. So we can just go ahead and replace y with 2, and we're going to get the answer for x. Let's go ahead and do that now. So our original equation is x squared minus 2y squared is equal to 1. Now I know that y is equal to 2. So if I do that, 2 times 2 squared is 8. So x squared minus 8 is equal to 1. Simple arithmetic, algebra, whatever you call that. X squared equals 9. Obviously, x is not going to be negative because we're looking for prime solutions. from here, we can safely say that x is equal to 3. So our solution set is going to be, or if you can call that, if you want to call that an ordered pair, 3 comma 2 is going to be the only ordered pair. That's the solution to the original equation, which was x squared minus 2y squared equals 1. Well, that brings us to the end of this video. I hope you enjoyed it. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.